afternoon, teacher.
Good afternoon, Panya. Good afternoon. Good afternoon.
Good afternoon, teacher.
Afternoon. Let me try to share the screen, okay? It's the attendance sheet. Good afternoon, Pam. Good afternoon, Pam. Good afternoon, Pukpong.
Afternoon, teacher.
Afternoon. Good afternoon, Kankawi.
Good afternoon, teacher.
Afternoon. Good afternoon, Kahom.
Yes, good afternoon, teacher.
Pukpong. You're wearing glasses. Sunglasses. Is that a sunglass? Good afternoon, Tay. Let's wait, okay? You can get your science book while you wait for your friends. Get your science book. So you had your exam, right? On Tuesday and on Wednesday. How was it? How was your exam, Pukpong? Good?
Yeah.
How did you do? Did you do well?
Yeah, bro.
That's good then. How about Kankawi? How was your exam, Kankawi?
So.
So. How about Kahom? How was your exam?
It's a little bit hard for me, but I can do it.
Oh, okay. So your exams were in Thai, right? All of the exams were in Thai. Thai classes. So it's 1:30. So I'll take attendance now, okay? If you're present, say I'm present. So today is 14th January 2022. Okay, let's first start with kan. Is kan here? Not yet, right? Kan. Okay, so I'll put it absent here. C is here. Okay, best. Is best here? Stop. Stop here. All right. Khao kong. Khao kong. No, right? Prim. Is prim here? Okay. Krawan.
Our teacher Krawan, she left for errands, so she can't come.
She left where? She left for what? She went
Errands.
Oh, okay. To run errands, right?
Yes.
Mutta. How about mutta? Is mutta here? No, right? Ja. Is ja here? No, view is not here as well, right? Pam is here. Pukpong is here. Im. Im, are you here, Im? No. Te. I saw Te.
Yeah, teacher.
Okay, Te is here. Panya.
Present.
Present. Kan. There's two kan here, right?
Yes, present.
This kan is present, right? Okay. Noi. Noi. Shampoo. Ingfa. Tawan. Guide. Are you here, guide? Cow home is here. Okay. So let's see this. Okay, someone sent me a message here. Who is this? I am here. What is your name? Best, right? Okay. Best. Best. Let's see best number. Okay, best present. Have I missed anyone or did someone just join in? Top. The top is present. Okay. That's it, right? I have called everyone's name, right? I haven't missed any one of you, right? Okay. I'm gonna save it now. All right, so let's start. So in our last class, we have been studying about this chapter, right? Which is about heat, chapter 6. And we couldn't finish this chapter. We have done like half of it, and in the middle, we left it there, right? We have done it until which topic? The sources of heat, right? And then we left it there. And also we studied about heat and temperature. And today we will start from where we left. It's about the effects of heat on matters, okay? So our topic is going to be effects of heat on matters, okay? So to do that, I want you guys to take a note as well, okay? Because in your book, there's the note given here, right? The information given here in your book is too less. I wonder how you guys study. Okay, so that's why teacher wants you guys to take a note so that you remember next time when you review, okay, the topics that I've taught. And later on, we will be doing exercises on page 75, exercise 6.2. Okay, there is 1 and we will also do another exercise on page 76. Okay, so we'll be doing two of these exercises. Okay, now I will share my screen. Okay, effects of heat on matter. Okay, our topic is about effects of heat on matter. All right, when the matter, right? So there are how many states of matter? We have 3 states of matter, right? Solid, liquid, and gas. We have 3 states, solid, liquid, and gas. So when the matter gains, okay, when the matter gains or loses heat, okay, they will undergo some changes, okay? So they are called expansion or contractions, okay? B, changes in temperature, and C, changes in states of matter. So there's 3, okay? The states of matter will undergo these 3 changes, okay? So our today's main focus, okay, is gonna be on expansion or contractions, all right? So to do that, let's first know the meanings, all right? So first, I want someone to read the sentence. Kankawi, can you please read the sentence for teacher?
Yes.
Can you please read it?
Increase in the size of the object when they are hot is cold. Expansions.
Okay, Kankawi. Okay. Okay, so first one is about expansion here, okay, the definition. So what does expansion mean? So expansion is increase in the size, okay, increase in the size of an object when they are hot is called as expansion. Okay, everyone? Second one, let's learn what contraction means. I want best. Best, can you read the second sentence, please? Best, teacher cannot hear you. Can you please read the sentence?
Decrease in the size when they are cool is called
Contraction. Okay, best.
contraction.
Okay, very good. Best in Kankawi. Very good. So decrease in the size. Okay, decrease in the size when they are cooled is called as contraction. Can you see the difference here? Increase in the size of an object. Okay, increase in the size of an object is called as expansions. Okay, decrease in the size, okay, when they are cooled is called as contraction. Okay, everyone, don't get confused here. If you want to take a note, please take a note of this one so that you don't get confused, okay? Because we will be using these 2 words a lot for this topic, okay? Expansion means increasing in size, becoming larger, bigger, okay? When the matter is heated, okay, when the matter gets hot. Decrease in size, becoming smaller, okay, when they are cooled is called as contraction. All right, understand, everyone? And third word I want you guys to remember is vigorously. Vigorously means with force and energy. Okay, with force and energy, you move things, okay? Or maybe the particles inside, okay? Particles inside the solid, liquid, or solid, the particle inside the solid moves very hardly, That means vigorously, okay, with force and energy. Understand, everyone? So I want you guys to take a note for this one. Just make a small note in your book so that you don't forget it. Everyone take a note. Write this down, just the important ones. Pen, write it down, pen. Okay, so let's move on to the next one. Okay, so let's look at expansion and contraction here. Okay, so most of the matters, most of the matters expands when heated and contract when it's cooled. Okay, so let's say for an example, a thin glass cracking, thin glass breaking when a hot water is poured into it. So let me ask this question to someone here. Kahom. So here, the example is thin glass cracking when the hot water is poured into it, right? So here, is it expansion or contraction here? See the hot water, right? When the hot water is added on to the glass cannot take it anymore, right? So the answer is contraction or expansion. Okay, it's
I think expansion.
yes, very good, Kahom. It's expansion because the person is adding onto the hot water, right? So it's expansion. Okay. Understand, everyone? Okay, now let's move on to the next one. I'm gonna keep my, okay. Expansion and contraction in solid. Let's look at in all three states of matter. So first, let's look at in the solid, okay? Expansion and contraction in solid. The atoms or molecules in the solid vibrate at all temperatures. So here is the expansion and contraction in solid when it's heated. Okay, when I heat on, the cold objects, what happened? The atoms or the molecules are in the solids, right? They will vibrate, okay? They will vibrate at all temperature, okay? And also, as the temperature increases, right? As the temperature increases in the solid, what happens? The atoms, they vibrate more vigorously. They vibrate more hardly towards each other. And that makes, or that pushes the atom even further. Okay, everyone, can you all see the sizes here? The sizes of the molecules inside the solid was first like this, right? But when they have added the heat on, what happened? The sizes have also increased because it has expanded, right? Understand, everyone? Okay, now let's move on to the next one. Now let's look at expansion and contraction in solid when it's cool. All right, everyone? So here, when it's cool, what happens is when the solid is cooled, okay, the atoms vibrate less vigorously, okay, and become closer together. The atom becomes closer together now, okay? They doesn't vibrate that much like they did in hot one, right? So they vibrate vigorously, less vigorously, and become closer together, and volume of the solid also decreases and it contracts. Do you guys understand this? Please let me know if you don't get it, okay? So in the solid, did you get the differences now? In the solid, when the heat is added here, right? The atoms, right? They tend to vibrate more hardly towards each other. And that makes the atoms to push even further and make the sizes to increase, right? Whereas when it's cooled down, right? When it's cooled, what happens is the atom tends to move or vibrate less vigorously, not hard, okay? Less vigorously here, okay? And also when it cool down, the atoms become closer to each other, okay? Understand? And also the volume of the solid also decreases here and it's contract. Becoming contract means becoming lesser in size. Okay? Understand? Do you understand best?
Yes.
Okay. Now let's move on to the next one. So I want to ask you guys a question here. Okay. So here, the metal ball cannot pass through the ring when it's hot. Okay. So here, you can see that the metal ball has been heated, right? The person has already heated this metal ball, but now what happens is the metal ball cannot pass through this ring. So what is it? Is it expansion or contractions? I want to ask this to, hold on. C.
Yes, teacher.
Is it expansion or contraction here? The metal ball cannot pass through the ring anymore. What has happened to this metal ball now? Has it expand or has it contract? Okay. Okay, see, who can tell me the answer for this one?
Expand.
Okay, Kankavi, very good. It has been expand here or expansion, okay? Very good, Kankavi, because what happens is once we heat the solid things, right? It will try to increase, the sizes will increase. When it increases, we call it expand, right? Okay, very good, Kankavi. Now, let's look at the expansion and contractions in liquid, okay? When it's heated. So when the liquid is heated, okay, when the liquid is heated, the molecules of the liquid will have more energy and moves more vigorously here as well, okay? So these are the arrangements of the particles inside the liquid, okay? This is how it looks like in the cold, and this is how the arrangements of particle looks like in the hot, okay? So what happens when the liquid is heated here as well? It's almost same thing as in the solid here, right? So the molecules of the liquid will have more energy and it tries to move more vigorously, okay, everyone? And what happens is it also allows them to have a greater freedom for the molecules to move. Before it was grouped together, right? Now you can see the spaces have grown. You can see the spaces, right? It has some spaces for the liquid molecules to move around. Okay, do you get it, everyone? Let's go to the next one. Expansion and contractions in liquid when it's cooled. Okay, so at a lower temperature, okay, the molecules of the liquid have less energy. Okay, that time when it was heated, right, they have more energy and it tends to move more vigorously, right, more hardly. Now, what happens is because of its lower temperature, because it's cold, right, the energy of the liquid will also be less, okay? And it tends to move closer to each other, all right? And the volume of the liquid also decrease and liquid contracts here. Do you understand, everyone? So you see the difference, right? Contraction and expansion. Contractions happens when the temperature decreases, okay? And expansion happens when what happened? When the temperature increases, okay? When the things are hot, the expansion is likely to occur. Do you guys understand, everyone? Say something.
Yes.
Yes, right? Okay. Now, let's move on to the next one. Expansion and contraction in gases. We have just talked about liquid, solid, and liquid, right? Now, we're going to talk about in the gases, okay? So here, in the gases, the molecules of the gases are far apart compared to the molecules in liquid and in solid. So we already know this, right? Everyone, in the solid, we know that the molecules are far apart, right? Compared to the molecules in liquid and solid. We already know this information, right? So the gas molecules moves at high speed in all directions. Okay, it always moves in high speed in all directions. The molecules inside the gases, okay? Because they have more spaces between the molecules. That's why they tend to move in high speed at all directions. So here, expansion and contraction in gases when it's heated. Okay, let's see. When the gas is heated, okay, when the gas is heated, the molecules become more energetic. It was already energetic, right? The molecules in the gases are already energetic, but when we add heat, it becomes more and more very energetic and tends to move very fast and are further apart, okay? And the volume of the gases also increase and it tends to expand. All right, everyone? Understand?
Yes.
Okay. Now let's move on to the next one. When it's cooled. Expansion and contraction in gases when it's cooled, okay? So at a lower temperature, what happens is, now there's no heat, okay? We're talking about the cold one, okay? So at a lower temperature, the molecules moves very slow, okay? Before, it was moving very fast, right? Now, because the heat has been removed, right? So what happens is molecules also moves very slow due to less energy. They don't have energy, okay? Because it has lower temperature now, right? So what happens is they become close together now. The molecules tends to move towards each other, close together, okay? And it also causes the volume of the gases to decrease and contraction occurs here. Do you guys understand now? Here, when the heat is added, okay, be it solid, liquid, or gas, okay, when the heat is added, what happens is the molecules tends to move faster and it also expands, right? Whereas when the solid, liquid, or gas, all three of them, when it decreases the temperature, when it is cold, right? What happens? They tends to decrease their sizes, right? The sizes become less, okay? The sizes become less and then they tend to move towards each other and the energy is also less comparing to when it's hot, okay? Understand, everyone? So with that, we have only 10 minutes. So I want you guys to turn to page number 75. I'm gonna write it here so that you don't ask me later on, teacher, what page? Page 75. Turn to page number 75, everyone. So since we have less time, right? So teacher is going to read the instruction. Actually, I thought of letting you guys read. So it's 6.2, exercise 6.2, effects of heat on matter. Okay, number 1, complete the sentences regarding the effects of heat on solid, liquid, and gases. Understand, everyone? So here, this is the picture. Let's see the observation here. Okay, so the observation, the metal ball cannot pass through the ring when it's hot. Okay, so this is the metal ball, everyone. I already gave you this example, right? So you already have this idea in your brain now. So this is the ring, and this is the metal ball, and this is the holder here. So it says, the observation says that the metal ball cannot pass through the ring. So the conclusion is, the metal ball, did it expand or did it contract? Pokpong.
Yeah.
Okay, what is the answer here? Pokpong? Expand or contract? Expand means,
The metal ball.
yes, the metal ball. What is the answer?
Anh nói chưa? Anh có nói chưa?
Okay, so the answer is, who can tell me the answer for this one? You can open your microphone.
Expansion.
Okay, very good. Kahom, it's expand or expansion, okay? So if we put it into a right sentence, we just call it expand here, all right? Let's see the explanation. All of you, please write this down, okay? Let's see the explanation here. The atoms in the metal ball dash more vigorously, okay, when heated and move away from one another. So what is the answer here? Who can tell me the answer for this one? Does it, here, what happens? The metal ball vibrates, right? It tends to vibrate, okay? So the answer here is vibrates. Atoms in the metal ball tends to vibrate more vigorously when it's heated and it moves away from one another. That's why the expansion has happened. It's because they have heated the metal ball. That's why. Done, everyone. Let's move on to next one. We are running out of time, okay? We only have 7 minutes. Next one, observation. Here, this is the flask. This is a hot water and this is a colored water inside the flask, okay? Observation, the water column in the tube rises when the flask is placed in a hot water. So the conclusion, the water in the flask, what happens? Does it contract or expand here? You can unmute your mic and answer. It says that the water column in the tube rises, right? What happened when the temperature rises? It expands. Okay, so the answer is expand here. Write this down, everyone. And let's look at the particles in the explanation part. The particles in the water in the flask dash energy and move further away. So they will tend to have more energy, right? The particles inside the flask. Let's see the third one, okay? This one. You can keep on writing and listening to teacher. So this one is the air, okay, inside the flask, right? And this one is a colored water droplet. So observation, the colored water droplet in the tube rises. Rises means when the temperature rises, what happens? It tends to expand here as well. So the answer here is expand here, okay? Because see here, he is, the person is holding the flask here, right? That means our hands are warm, right? Because of our hands, the temperature has risen up. Next explanation. The air in the flask absorbs dash from the hands. Absorbs what? What did I tell you? Our hands are warm, so it tends to absorb the heat from our hand, okay? And expands, and it pushes the color water droplet upward, okay? We have 3 minutes. We have one more at the back. It's gonna take time, so maybe I will let you guys take a picture.
Teacher, A.
Yes. Which one? A.
ข้อ A.
You didn't finish? Pam?
Number 1, A.
Is everyone done with this?
Teacher,
No, finish
Bang is no
A.
finish A.
Okay, okay.
Bang no finish is A. Number A เชื่อ
Hold
ข้อ
on.
A เชื่อ Bang is not finish
Okay.
choice 1
You can see this, right, everyone?
Finish, teacher.
Finish, Pam, finish. Okay, so for the next one, I want you guys to take a picture because we only have 2 minutes, so I don't think we will be able to finish this in the class. So I want you guys to take it as a homework and then write it down later on, okay? And I also want you guys to send it in the line group because I will be checking on your homeworks and your in-class exercises. Done, right? Now let's move on to the next one. Can you all, do you have your phones, everyone? Please take picture of this and then make sure you write it in your book. Okay, so for the explanation, I will explain you in the next class because we are running out of time. Take a picture, everyone. Take a picture of this. I will give you 10 seconds. I'll give you 20 seconds to take picture. 15 seconds, okay. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Everyone, I will stop sharing the screen now, okay? Okay, so with this, we are done with our class and I will see you guys next Friday. Okay, so till then, take care, be safe. Okay, and don't go to crowded places. Okay, always wear a mask and wash your hands and apply sanitizer every time you go outside. Okay, so take care, everyone. Bye bye. I'll see you guys next week.
Thank you, teacher. Take care.
Okay, bye bye.